Alright, welcome to the video for lesson number 3 and lesson number 4's homework assignments. So in lesson number 3, we talked about how parallel lines can also create these proportional sides, essentially an extension of the side splitter theorem. So in this first question, we're going through and seeing that this segment of 7.5 becomes 18, the same way that 6.5 becomes x. So if we set up a proportion here, I could say 7.5 over 18 is equal to 6.5 over x. Cross multiply, and we get 7x is equal to 7.5x, sorry, is equal to whatever 18 times 6.5 is, which is 117. Divide both sides by 7.5. And we get x equals whatever that comes out to be, 15.6. So if we look here at number 2, number 2 tells us that all three of these lines are parallel to each other. So again, we're going to wind up having that situation where the opposite sides that are non-parallel are proportional, or the same proportion. It says AB is 7. It says CD is 4. It tells us FD is 6. And it tells us that these two sides are in a ratio of 1 to 4, meaning these two sides are also in a ratio of 1 to 4. Well, if 6 is the larger piece of a ratio, I'm essentially asking myself, what multiplies by 4 to make 6, or what is a fourth of 6? And that's going to be 1.5. So BF is 1.5. For AE and EC, I don't know either of them, so I'm going to make 1x and 4x. Then what we can do is really two things. We can either use the perimeter or set up some ratios to solve here. I'm going to use the perimeter because it gives us it. So the perimeter is 31, so I know the whole thing is 31, and the sides that I know are 7, 1.5, 6, 4, 4x, and x. So I can say 31 is equal to, if we combine some like terms, 7 plus 1.5 plus 6 plus 4 is 18.5 plus 5x. Subtract the 18.5 to the other side. So if I do 31 minus 18.5, I wind up getting 12.5 equals 5x. Divide by 5, and I get 2.5 for x. Now, if 2.5 is x, that right away tells me what AE is. And then to find EC, I would just multiply that number by 4, which makes 10. Number 3 was on our last test. So for number 3, a lot of people chose choice B. And I want to explain to you why choice B does not make sense. So because it says always true, in this one situation, it totally looks like AD and DE are perpendicular to each other. But if I was to make it so that they weren't, and I was to make B extend out to here, could those two triangles still be similar? And the answer is yes. So that doesn't necessarily have to be true. Could it be true? Sure, but it won't always be true. That's the kind of tough part about these questions. The other two choices that don't make sense are A and C. So it does look like AB times 2 would become AD. It looks like B is kind of in the middle. But if I was to draw BC up here, it still would be a dilation. It just wouldn't be a scale factor of 2. It might be 4 or 6 or something like that. The same thing applies for part C, right? AC and CE totally looks like they're the same length, but if BC was drawn up here, they wouldn't be. So these three, although look true in my picture, are not always going to be true. The only one that's always true is no matter where I draw BC, even if I was to draw it down here, it would still be parallel to that base. Otherwise, they wouldn't be a set of dilated figures. Number 4 is another regions question. I'm asked to find the distance across the lake. So if I redraw my two triangles, so if I have a triangle of ADE, I notice that AE is 230 and DE is 120. Then if I draw the bigger triangle, I have A, B, C. BC I don't know. And AC, I have to do some work first before I figure out. I got to add those two numbers up to get 315. Once I know that, I can set up my proportion. So the side of the side of 230 becomes the side of 315. The same way that the side of 120 becomes x. Cross multiply, I got 230x is equal to whatever 315 times 120 is. It's a big number, I think, right? 37,800. Divide by 230. And we see that x, or the distance across the pond, comes out to be 164 yards. It's a decimal, but it doesn't say what to round to, I don't think, so I'm just going to round to the nearest whole number. All right, we all know how to round, so we can do that from here on out. Number 5 you actually did in lesson number 2's homework as an extension kind of added piece. So if you got 6.6 for number 5 when you handed in the other day, awesome, you can move on to the next part of the video. If you didn't, take a minute here to see how the answer comes out to be 6.6. So for this, it says that we have this flagpole. So for this, it says that we have this flagpole here, and we can go through and say that we don't know the height of the flagpole. We do, however, know that the flagpole has this shadow of 16.6. And Tim here stands 1.65 meters tall, and he's standing 12.45 meters away from the flagpole. So I need to figure out, well, how big is Tim's shadow? 16.6 minus 12.45 tells us Tim's shadow is 4.15. So if I redraw the two triangles, so here's one, x and 16.6, and here's the other, well, not that one was a pretty bad triangle, and here's the other, 1.65 and 4.15. So I can say x compares to 1.65 the same way that 16.6 compares to 4.15. Do some cross multiplication, and we get 6.6 for my answer. All right, let's look at lesson number 4's homework. So for lesson number 4's homework, there's a main concept that we learned in the lesson today, and that's that the sides ratio is the same as the perimeters ratio, and the sides ratio squared is the same as the areas ratio. So it depends on what you're given as to what one you're going to use. So here in this first example, it tells us that we have two triangles. One has sides of 6, 4, and 8. The other one, which we don't know pretty much anything about, has a perimeter of 27, and it says that we want to find the shortest side. So the shortest side would be opposite 4, so I'll make that x. Now, it doesn't look like you know more about the smaller shape, but you actually do. The smaller shape has a perimeter of 18. So because the perimeters ratio is the same as the sides ratio, I can say 18 becomes 27 at the same ratio that 4 becomes x. So if I cross multiply, I have 18x is equal to 27 times 4, which is 108. Divide both sides by 18, and we get x is equal to 6. And looks, I skipped number 1. So let's go back to number 1. I apologize for that. I don't know how that happened. So if we look at the sides of a triangle here of 4, 8, and 10, and the second triangle has the shortest side of 12, it says find the length of the missing sides. So you can set up a proportion here, you can do all that work, but if you're really good, you notice that 4 becomes 12 by multiplying by 3, so 10 becomes 30, and 8 becomes 24. That one you really didn't need ratios for. You could have just went with the multiplication part. Probably why I skipped that one. So easy. So let's look at number 3. So number 3 says that we have two similar triangles and the pair of sides has a ratio of 5 to 3. And we want the ratio of the areas. Since we know the area is going to be the sides ratio squared, we can do 5 squared, 3 squared, so 25 compares to 9. Number 4 is kind of a tricky question. So it gives us the areas ratio and it wants us to find the volumes ratio. Well, I know that the volumes ratio is the sides ratio cubed, and I know the areas ratio is the sides ratio squared. So if I wanted to find the sides ratio, it would be 3 to 4, because 3 squared makes 9 and 4 squared makes 16, meaning the volumes ratio has to be 3 cubed, 4 cubed, or 27 to 64. Number 5 gives us a similar question to like what we did in class. So it tells us that angle H is the same as angle RDO. So if I redraw these triangles, I have CHR with H labeled. R is going to be the same in both. And if I turn this smaller triangle around a little bit, I'm going to wind up getting a triangle that has this angle as D, this angle as R, and then O would have to be the remaining angle up top. It says from R to D is 4. It says from R to O is 6. And it says from O to H is 4. O to H is not in either triangle, but if you notice HR is, and we know now that HR is 10. And it wants us to find CD. CD is also not in a triangle, so I have to find the side that has CD as part of it. So CR would be the side we're looking for. So when we solve for x, it's not going to be our answer. We have to kind of check and see what we get here. So I see that x becomes 6 and 10 becomes 4. So if I cross multiply, I have 4x is equal to 60, or x equals 15. 15 is your distractor answer. It's not the answer. 15 is the length from C to R. So if dr is 4 and C to R is 15, C to D is 11. Now let's take the same question and do some added stuff to it. So here is our two triangles again. It says in the two triangles, the smaller one, RDO, has a perimeter of 15 and an area of 24. And it wants us to find the perimeter and the area of the larger triangle. So one of the things we know is that the perimeter's ratio is the same as the sides. So if I pick one set of corresponding sides, they're going to have the same ratio as the perimeters. So the sides are in a ratio of 6 to 15, which reduces to 2 to 5. So I can say 2 to 5 is the same thing as 15 to the perimeter. Cross multiply, 2 times the perimeter is equal to 75, divide by 2, and I see that the perimeter of that larger piece is 37.5. If you didn't reduce your ratios, it's not wrong. The only reason why I reduced the ratio here for the sides and perimeter is because I'm eventually going to need that reduced ratio to figure out the ratio for the areas. So because the ratio for the perimeters is 2 to 5, the ratio of the areas ratio is going to become 2 squared, 5 squared, or 4 to 25. So if the ratio of the area is 4 to 25, and the smaller area is 24, I can figure out the bigger area by solving this problem. So we get 4a equals 25 times 24, which is 600, divide by 4, and I see the area winds up being 150. And that's it. So hopefully you got something out of this video. I know I'm posting 2 homework videos in a row here for the last couple days. It's just a little bit easier for me to do that way. Make sure that you're doing all of your work, and don't forget about your weekly assignment that's due on Friday. All right. Best of luck.